So this is a quick, somewhat low budget recording of the notes I was going to help you guys with today. All right, here we go. We're talking about similar polygons. So polygons with the same shape but different size are similar. Congruent polygons are the same size, same shape. So polygons are similar if all corresponding angles are congruent and all pairs of corresponding sides are in proportion. I'll explain what that means in a bit here. You'll see it. Or are proportional. Out of room. All right, so the ratio of corresponding sides is called the scale factor. If polygons are similar, then their perimeters are also proportional. So here's an example. So we want to know what's the scale factor of triangle ABC to DEF. Now, it's important that we match up corresponding sides and corresponding angles, just like we did when we were talking about congruence. So I can see that angle A and angle B are congruent respectively to D and E. That means that side AB must be corresponding with side DE. So my scale factor of ABC to triangle DEF is 8 from side AB to 12 from side DE. Now the order matters because if I want to know ABC to DEF, I have to start with triangle ABC. And I'm going to simplify this down to 2 to 3. So that's my scale factor. Now my scale factor of DEF to ABC, it's just a different order. So instead of being 8 to 12, it's 12 to 8, which simplifies to 3 to 2. Now I could have chosen any pair of corresponding sides and it would have simplified down to the same ratio. So if, for example, I had chosen to compare, let's see, it looks like side BC is corresponding to EF. Notice that 10 to 15 simplifies right down to 2 to 3. So every pair of corresponding sides of your polygons, if they're similar, will simplify down to the same ratio. And now it wants to know what's the ratio of the perimeter of triangle DEF to ABC. Well, that will be the exact same as the ratio as the scale factor up here. So it must also be 3 to 2, which kind of makes sense because you're adding up sides to get perimeters. Now, similarity statements. First of all, you know the symbol for congruent, right? It looks like that. The symbol for similar is just the wiggle. That's how we say similar. Now, a valid similarity statement must match corresponding angles and sides, just like a valid congruent statement. So for the triangles above, we can start off by saying maybe triangle, I'll just say triangle ABC, makes sense to go in order, similar to triangle. So I see angle A is congruent to angle D, so I start with D. Let's see, now I have B, and B is congruent to E, so I have E. And then C is the only one left over, and that's congruent to F. So triangle ABC is similar to triangle DEF. Okay, so for this example, we're going to list all the congruent angles and write a proportion relating the corresponding sides. So first thing I'm going to do is I'm going to mark my diagram. So I see that J and P are corresponding, and I'm told the triangles are similar. So that means that J and P are congruent. Then I see K and M. Those are the next letters that show up, so I'll mark those. And then I've got L and N, so I'll mark those as well. I think I'll go ahead and mark some sides here as well. So let's see, so JK and PM, so there's JK and PM. And then it looks like I've also got KL and MN, so KL, MN, so those are corresponding. And then finally, that leaves me with my third pair of sides, JL and PN. So writing it over here, I can say angle J is congruent to angle P, angle K is congruent to angle M, and angle L is congruent to angle N. Now, to write a proportion with all the corresponding sides, it goes like this. Pick a triangle to start on. I'm going to pick this one to be my first triangle and this one to be my second. So I'm going to start by listing side JK over, okay, so JK corresponds to side PM. So that's JK over PM. And then I'll say equals. So whatever that ratio is, whatever that scale factor is, it's going to be the same as my other pairs of sides. So I also have KL over NM because I already marked those as corresponding. And we'll just extend this to say we are also equal to JL over NP. And I always like to double check myself and look back here and say, okay, every pair of sides up here, JK, KL, and JL, they all came from the same triangle. So I want to make sure I've got all one triangle across the top and all the other triangle across the bottom. I think we'll skip examples 2 and 3. It's pretty similar. I guess the only thing to think about with number 2, I guess not very much. They are kind of overlapping. So I'll come back and do example 2 at the end of this video if you still want to see it. If not, though, I'm going to kind of hop around a few different examples, and then I'll tell you when you can leave the video if you feel like you've got enough going on. Okay, so down to finding side lengths using proportions. So it says if the figures below are similar with a scale factor of 2 to 3, find the value of x. So that means that the ratio of this left-hand polygon to the right-hand polygon must be 2 to 3. Now I chose to write that scale factor this time as a fraction because that's going to help me write a proportion. So it's 2 to 3. So then I can just fill in the other side, keeping the same order. So this was the 2 to 3, so I'm going to do 42 to x. And then I can solve it with cross products. So that's going to be 2x equals, what is that, 126? So then x is 63. I did that in my head, so if I mess up my math, excuse me about that, but I think that's what we have there. So that's how that one works. Now let's look down at example 6. So this one, they're giving us a similarity statement first. So the thing you have to be careful of is that you match up the correct sides. So I like to label. All right, so we're told A, B, D, E. So here's A, B, here's D, E. And then we're told B, C, and E, F. So here's BC and EF. And finally, we've got AC and DF. So I'm going to make a ratio with those corresponding sides. So I know I'm looking for X here. So I think I'll start with X on top and put its corresponding side on the bottom. So X over 25. And then I need to use another pair of sides. Well, the blue sides don't make any sense because I don't have any numbers there. But I can use the purple sides. So that's going to be 28 over 20. So I made sure that my top of my proportions are coming from the same triangle and the denominators are coming from a different one. Now, there are other ways to write that proportion. In fact, last class we talked about different ways you can write the same proportion. So that's fine if you do that. I'm going to solve this. I think before I solve it, I'm going to simplify 28 20ths because I can. I can divide them both by 4 to make that be 7/5. So now I have x over 25 equals 7/5. I could do some cross products here, or I could say, hey, 5 times 5 is 25. So I can just do 7 times 5 and get 35. But you could, of course, do cross products in there and get the same thing. So that's the main idea with those. So at this point, I have covered the main pieces here. I'm going to end this video now and then do a separate video with extra examples if you feel like you need a couple more.